Okay, welcome to Grade 10 Math with Mr. Murphy. We are in Unit 2, Chapter 4, and Lesson 3, Modeling with Formulas. By the end of today's lesson, you'll be able to rearrange formulas to solve for a particular variable. Here's a mind-blowing question, starting from where we left off from last lesson. So I want you to try and solve, expand and then solve for P. So pause the video and try it out. Okay, now that you've tried it out, let's take it up together. The thinner pen here. Okay, so 5.6 times 4 gives us 22.4 p. 5.6 times 4 again, it's going to be the same number, 22.4 and 49.28. This side didn't change. We're going to subtract 22.4 on both sides because we want to get rid of this unlike term to the p. So that's going to give us 22.4p equals 2688 after we subtract 49.28 minus 22.4. All right, so then we're left with this number, the coefficient to the p. We want to get rid of that. So we divide 22.4 and 22.4. And so we get the p all by itself now. And that goes into that number 1.2 times. Of course, we learned yesterday, last lesson, it's always to check. So 5.6 times 4p plus 4 equals 49.28. All right, and then we're going to put the 1.2 in for the p. So 5.6 times 4 is 1.2 plus 4, and the 49.28 doesn't change. Okay, so right now we're going to look at this right here. We can probably do all of this in one shot. So this is going to be 4.8 plus 4. 4.8 plus 4 will be 8.8 times what was already there, 5.6 equals 49.28. Okay, so that gives us a good multiply that out, and we get 49.28, which is equal to the right side, 49.28. So our left side equals our right side, which means we are correct. All right, so the whole key to today's lesson is understanding the difference between just having a regular equation versus having a formula. Well, a formula describes an algebraic relationship between two or more variables. So you could have things like slope and like a y-axis and a x-axis. So you could have width and area, and those would be two different variables. Now, solving for a formula, well, we follow the steps we would to solve an equation. So in this case, you'll notice you have two variables. Well, which one do we solve for? Well, they tell us. So solve for y means to isolate. So solve for y means to isolate. Can we get y all by itself? So we have to reverse what's going on here. The first thing we want to do is recognize that we want to get rid of the brackets. That was one thing we learned yesterday. So I don't think I'm going to touch the x yet. There's nothing to do there. We're going to distribute these in the 3. So 3y minus 3. Okay, now what's happening to y? Well, the y is being multiplied by 3 and subtracted by 3. So remember that bed mass, we're trying to do backwards. So do you see any addition subtraction? Yes. So we're going to subtract 3 on both sides. So we have x minus 3 equals 3y. All right. Now we have multiplication going on. So we want to do the inverse of that. Divide both sides by 3. Usually when we do that, we do it all over something. But I'm going to show you what we can do in the end with that. We get y by itself. And these can split. So we have x over 3 minus 3 over 3. Well, of course, we don't want to leave it like that. Give myself some more room there. We can simplify it a little better. So we would have x over 3 minus, this would make 1. So that would be our final answer there. Okay, in this next one, I want you to try it on your own. We're going to isolate the b here. Okay, so pause the video and try this. All right. Well, good job trying it. I hope you did. And we're going to reverse this, okay? I want to show you a little trick. Anytime I have a variable that is negative and I don't want the variable I'm looking to be negative, I'm going to switch it over to the other side. And I think over time, over practice, you're going to find that more easier. So I'm going to bring this over. And remember, what happens when we bring something over to the other side? It changes sign. So now it's a plus b. And the a is still here because we didn't talk about moving that yet. And the 5 is already parked over here. Like we just did with the b, we can switch this over. And so what do we have? We have b equals 5 minus a. It doesn't matter too much which one comes first. A lot of people like to have the variable first and then the constant. Some people, doesn't matter at all. Some people don't want to have a negative first, so they'll put the 5 and then a negative. So either way is okay. All right, good. Let's keep going. So let's pause right now, and I want you to try C all by yourself. So press pause. All right, welcome back. We're going to try this together now. All right, so we want to isolate V. So what is happening to the V? Well, it never hurts to go back to some of the things we talked about before. It's being multiplied by -3, and it's being added by 1. So the inverse operations would be to subtract 1 and divide by -3 in that order, upwards. So let's do that. So, I'm just showing you different ways. I know I'm switching back and forth between ways that I've done things, but I'd like to show you, you can keep going back to your old ways of doing things. There's no right way or wrong way to solve these. So we put the -1 in both of those. We could have highlighted those with a different color. They stick out better. Okay, and then now we make this clear up a bit. U minus 1 equals, oh, don't forget the negative there, -3v, and those are gone now. The next thing that we would do is divide by -3. Divide each one. Well, you could do it separately, but it doesn't really help us in this case. -3. All right. So we have b is going to make it a positive b now. And we'll just leave it like that. U minus 1. And the only thing is we don't want to have that negative there. So screen Oh boy, yeah. So negative. We'll split that up a bit. Sorry. Just because of the negative, I'm not a big fan of that. So when you have a negative on the bottom, it's easier to split things up like this. And I'll show you what to do there. Okay, so the negative should always be on the top. So we have negative u over 3 plus 1 over 3 equals b. All right, very good. All right, let's move along to our next question. You can pause the video and try this one out again. All right, let's get going again and try this together. All right, so we want to get the y all by itself. So the first thing that we want to get rid of is, again, well, you notice that it's a negative again. So we might want to get the negative over to the other side. At the same time, we could probably move the 1 over. So now I'm combining a few steps here, see if you can keep up. All right, so if I brought the negative 2 over, it would be a positive 2y, and the 4x didn't go anywhere. And the other thing that came over was the 1, so it's a negative 1. All right, so in what we've done in many steps before, it took us, one step to do it this time. Not too bad, eh? All right, so to get the y by itself, I now have to divide each term by 2. And you might say, why didn't we just make it one big line over the 2? Well, I think we could do some reducing here, because you look at the numbers like 4 and 2, you're going to be able to reduce. So y equals 2 goes into 4 2 times, and left 1 half. That works out pretty good. Okay, gets a little more tricky, I guess, as we go along. This one now, notice we have 3 variables. Well, don't let that change anything you've done in the past. Really, all we're trying to do is get that all by itself. Now we have another example where this is negative. So I'm going to move that over. I'm going to start with this. I'm going to be a little more careful just doing one step at a time because it does look a little more complicated than the ones we've seen before. So the U stays there. It didn't go anywhere. The T is still here waiting. And this left. But this is still here. The 1 is still there. Okay. Now these U and V, don't make the mistake that they look a lot the same, but you want to make sure you're going to move that U over now. Okay. So the 2V equals, maybe you want to go alphabetical here. T plus the U plus the 1. You have to often do variables before regular constant numbers. So the only thing left to do now is we have the 2 divided by times the v. So we want to divide each term by 2. And that's going to cancel there. We have v equals, well, there is no chance for reductions here. You can't reduce anything. So since the denominator is all the same, we can make it all over 2. I think in this class I would accept either one of those as pretty good answers. Yeah. So we could say that's 4. Okay. Sorry, well, I mean, without these 2's, this would be a good answer. All right. Great. Well, sometimes we use things in math that we could help with science. In science, we did, you may have done speed, distance, and time problems. You might remember that often a science teacher will use a triangle formula to make it easier to remember. So it's distance and speed and time. And so what happens is when you go and you say, okay, I'm looking for speed, like this is the one I'm looking for. Well, then it's d over t, meaning division. Let's say I'm looking for time. I want to solve time. Well, time is equal to d over s. And finally, what if I'm looking for distance? Well, these are side by side, meaning it's like they're in brackets, and that means multiplication. Okay, with knowing that, that's sort of the shortcut. But let's use what we learned today to isolate and solve. Okay, so Harvey is training on a track team. He can run 100 meters in 20 seconds. Doesn't seem very fast. Maybe he's a small child, I guess, or something, but he wouldn't make the Olympics with that time. Okay, so what is Harvey's speed? Okay, we know his distance. We know his time. So S equals distance over time. There's no rearranging here because we have the S already figured out. So S is a distance of 100 divided by a time of 20. His speed reduces 5. And again, we have to get the units straight, meters per second. The meters per second are right there. We have 100 meters per second. That's how we come up with these units. So make sure you're writing those units. So therefore, Harvey's speed is 5 meters per second. Okay, next. Well, this is where the rearranging comes in. So don't look at your triangle because that would be cheating. So instead, look at your formula here. So how far Harvey can run in 3 minutes? Not a very good question here, but they've done the conversion for us already, which is really nice. We're going to start off with our S equals D over T. We have to find how far, which means how far is distance. Okay, that's what we're looking for. So that's what we're going to isolate. So to get DL by itself, we have division of time. So we must multiply both sides by T. Just want it to look visually like a different color. So D over T. So what does that do? Well, it cancels these out. And so we have, I like to have things in alphabetical order first. So ST equals T. So now that we have that, we can use our numbers. Now we're going to have to borrow the answer in A to give us the speed. So also, you can also rewrite it so the D is the thing on the left and the ST is on the right. So D equals, well, you got to borrow this from here, okay? And so our speed is 5. Our time is 180. We're getting that from here. And so our distance is 900 meters. So therefore, RV will run 900 meters in 3 minutes. Good. Okay, last one. I think I should let you try these again on your own without really skipping right to it. So if you want to pause the video, stop that. We'll try it out. Okay, so good. Let's start again with our equation. So our basic equation is S equals D over T. This time, how long means we're looking for time, I guess, because they gave us the distance. So we need to rearrange it for time now. Now, you may remember, like we've done other recap lessons where we did cross multiply. Even trigonometry, you guys got really good at cross multiplying. So if t is going to cross upwards, and eventually we're going to have to divide s anyways, it could cross downwards. So they can pretty much switch places. All right, so if we do that, then time equals the distance of 1,500 meters divided by the speed, which we had from before, 5 meters per second. Of course, when we reduce that, the m's cancel out, so we're left with just seconds. And that's what we want for time, and we get 300 seconds. So it will take RV 300 seconds to run 1,500 meters. Okay, great. Let's move on. One more question here. All right, John bought a new television for $540. This was the total cost, including a delivery charge of $120 plus the taxes of $13. Determine the cost of the television before the delivery charge and taxes. Well, we want to know the total, okay, of the cost of the TV. So let's see, C is the cost. So T is the total. C is the original cost. Okay, plus he's going to have 1 point. What's that as a decimal? 0.13. 1.3, and that's applied to the same cost as the original. We have to put that again a second time. And I don't know, we got D for delivery charge if we want to have another D here plus D. So let's fill in what we know. We know that the total cost of the television was $540. And there's kind of a number in front here. It's like there's a 1 here. So when we add 1 and 0.13, we get 1.13 of the cost plus the 120 just to get it delivered. Now, I'm sure you go shopping once in a while and someone along the line said, like when you're buying something, you go, okay, I want to know how much tax I'm going to have to pay. And some people say, well, I don't want to know just the tax. I actually want to know the total amount. So the sticker on the price with the tax involved. So often people say, well, just multiply by 1.13. That's what I mean. You're multiplying the original cost with the 1, and then the tax is added on as a percentage. Okay, really now this comes down to like terms and unlike terms. Here is a like term, and there's no other term like that. But we have two terms like this. So what we want to do is bring that over. Or maybe, you know what, let's just show it like this, like minus 120. And what I do to the right side, I must do to the left, minus 120. So what does that give us? Well, 540 minus 120 is 420. and that eliminates on this side. We have 1.13. I don't need a period there anymore. Okay, so we want to get C alone. Let's divide both sides by 1.13. And we get C equals 371.68. This is dollars. That is the original price of the TV. Therefore, John's TV would cost 371.68 before tax and delivery. That's it. Those are the type of problems that you can expect to um, have in this unit going forward. Now, today, when you have a chance, or this week, you're going to do your homework of BLM 4.3.1. Sorry, 4.3.1. Very good. And plus, some mathematics is always um, assigned for you if you want extra practice or if you like the online platform better. Okay, thank you for tuning in. We'll see you next lesson.